So limiting and access reagent, whenever a chemical reaction occurs, example, we have a reaction between calcium carbonate, CaCO3, when it reacts with HCl. As a result, when the reaction occurs, it gives calcium chloride plus carbon dioxide plus water. The state of calcium carbonate, that is solid, and all the acids and alkalis are aqueous, so HCl is aqueous. So when this reaction occurs, there are two possibilities. Number one, that example, this is HCl. In a container or in a flask or a beaker, we have HCl, and we add calcium carbonate, we add CaCO3. So when we add CaCO3, we add too much CaCO3 that there is some of the calcium carbonate is unreacted, means does not react. So when we compare the two reactants here, one of the reactant is a limiting reactant or limiting reagent, you can also say. Another one is an excess reagent. Excess means we have more than enough or extra. So example, we are adding calcium carbonate. Calcium carbonate is solid at room temperature. So when we add this calcium carbonate to hydrochloric acid, it will give calcium chloride, carbon dioxide, bubbles will be there, and water is also produced. As a result of this reaction, we add too much calcium carbonate. So when we add too much calcium carbonate, so what we will say? We will say the calcium carbonate is in excess. Excess means more than enough, where HCl is a limiting reagent. So limiting reagent is the one which used up completely, where excess reagent is the one when the chemical reaction finish or end, it's still left in the mixture. Is it clear, the concept of limiting and access reagents?
Yes, sir.
So how to work out a limiting or access reagents? How we can find which reagent is a limiting reagent and which one is an access reagent? For that, we have to use the mole ratios, or we have to use the mass ratio, or we have to use the volume ratio. So I will solve some questions. You will have an understanding how we can do these type of questions. Example, in a question, 0.07 moles of silicon reacted with 25 grams of bromine. Which one is a limiting reagent, and explain your choice. So how to work out a limiting or access reagent? We will always compare their moles. So we have the moles of silicon which are 0.07. But we don't have the moles of bromine, we have the mass of a bromine. So first thing, because whenever we are comparing the reagents, both of them should be in the same unit, and it is better you can have both of them in the moles, so it will be easy to compare. So first what we will do, we will find the moles of the bromine. So how to get the moles of the bromine from the mass? The formula moles equals mass in gram divided by the molar mass. So mass in gram is 25 divided by molar mass. How to work out the molar mass? You have to use a periodic table. When you check the periodic table, bromine is 80. The mass of a bromine is 80. And bromine, because it is a molecule, so what will be the molar mass? It will be 80 multiplied by 2. From where I get 80? This 80 from the periodic table. So this will be 25 divided by 160. So when 25 is divided by 160.
Mister, we multiplied it by 2 because 2 bromine.
Yeah, because bromine, for a non-metal, except group 4 and group 8, all the non-metal exists as a diatomic molecule. So if there was oxygen, it will be 16 multiplied by 2. If there was nitrogen, it will be 14 multiplied by 2. It's a bromine, which is Br2. That's why it is 80 multiplied by 2.
2, yes, okay, miss.
So then 25 divided by 160 will get 0.156 moles of bromine. Now, how to work out which one is a limiting reagent and which one is an access reagent? Simply we'll use a ratio. What ratio we'll take? We'll take a ratio between, according to equation. So what is the ratio according to equation between the two reactants? So ratio between them, if we have one silicon, how many bromine should be there? There should be two bromine. So if we have 0.07 silicon, how many bromine should be there? How many bromine should react? X. Cross
So, Mr.
multiply.
Cross multiplication,
Yeah, so
0.07
0.07 multiplied by 2. So
over 1.
0.14. So means we need 0.14 moles of a bromine for a reaction. This is what we need for a complete reaction. But how many moles we have? We have 0.156 moles of a bromine. So for a complete reaction, we need only 0.14, but we have more than what we need. We have 0.15 moles. So what does it mean? It means that bromine is in excess. If bromine is in excess, like more than enough, so which one is a limiting reagent? So silicon will be the limiting reagent. The next part, we need how many moles of a silicon bromide are there, SiBr2. So whenever we find the product, we always find the product from the limiting reagent. So what ratio we should take? Because we don't know anything about silicon bromide, tetrabromide. So we'll take a ratio between the limiting reagent, which is silicon, to silicon bromide. So the ratio between them, if we have one silicon, we will have 1 mole of silicon tetrabromide, which is 1:1. And in the question, how many moles of silicon are there? We have 0.07 moles. So 0.07. So how many moles of silicon bromide will be there? X. We cross multiply, we'll get 0.07 moles of silicon tetrabromide. Why I did not use bromine here? Because if I use a bromine, I will get a wrong answer, as bromine is an excess reagent. Excess reagents does not completely used up. That's why you will never use the excess reagent to calculate the amount of product. So we always use the limiting reagent to calculate the amount of product. Is it clear?
Yes, Mr. Clear.
Another example. So whenever you want to find a limiting or excess reagent, you will always use the moles to compare them. In this question, 4.8 grams of calcium is added to 3.6 grams of water. The following reaction occurs. The first part, the
So,
number.
Mr. It will be 48
Yes?
over the number of calcium in periodic table.
Yeah, that is 40. And calcium is a metal. For metals, it will be only an atomic mass, not the molecule. Here,
1.
yeah, 1. The periodic table is there in the beginning. So this one is a periodic table. You can see we have calcium, which belongs to group 2. So calcium atomic mass is 40. And the next one is water, which is H2O. So water contains 2 hydrogen and 1 oxygen. So hydrogen is 1 multiplied by 2 plus oxygen. Here you can see 1 oxygen, so 16. So 1 plus, so 2 multiplied by 1 is 2 plus 16. So total will be 18. So we want to find the first part. We want to find the moles of calcium. How to get the moles of calcium? Mass in gram, which is 4.8 divided by
18.
No, calcium is 40. Water is
Yes,
80.
okay.
So 4.8 divided by 40, that's equal to 0.12. So we have 0.12 moles of calcium, and 3.6 divided by 18, because the atomic molecular mass of water is 18. So 3.6 divided by 18, that's equal to 0.2. So these are the moles which we have. Now we want to find which one is a limiting, which reagent is in excess. So for that, we will use a ratio. So example, calcium and water. What is the ratio according to equation? If we have one calcium, we'll have two water. So the ratio between them will be 1:2. So if we have 0.12 of calcium, how many water will be there? X. We cross multiply. So when we cross multiply, what is the value of X? 0.12 multiplied by 2, that is equals to 0.24 moles of water. So this is what we need for a complete reaction. We need 0.24 moles for a complete reaction, but we have 0.20 moles of water. So what it shows that we don't have sufficient water for a complete reaction. We need 0.24 moles, but we don't have 0.24 moles. Yes, you can take ratio of water to X also. It does not make difference. Any one of them you can consider as X and compare. I will solve the question with both. First, I'm solving with considering water as X, and then I will consider calcium as X. You'll get the same answer. It does not make difference. So here for a complete reaction, we need 0.24 moles, but we have only 0.2 moles. So it means water is a limiting reagent and calcium is an excess. Like we have more calcium for a complete reaction as compared to water. You can also solve this question by other way around. So 1:2 is the ratio between calcium and water. So if I have 0.2 moles of or 0.20 moles of water, how many moles of calcium we need? X. Cross multiply. So when you solve, it will be 2x is equals to 0.2. So 2x is equals to 0.2 or x is equals to 0.1. So these are the moles of calcium which we need, but we have 0.120. So it means we have more than what we need. So it means the calcium is in excess or water is the limiting reagent. Is it clear? So both ways, when you solve, you will get the same result. It does not make difference. These are the moles of calcium which we have, and these are the moles of calcium which will react. 0.12 moles. How do we know which one we need? You have to consider, you can consider any one of them as X. Like it does not make difference. I can consider, like I have calcium and water. First, I will write the ratio according to equation 1:2. So if I say I have 0.12 moles of calcium, then X moles of water are needed. So when we cross multiply, it means 0.24 moles of water are needed for a complete reaction. But we don't have 0.24, we have only 0.20. So that also shows that water is a limiting reagent. So you can solve by considering any one of them as X. It's up to you. You can consider the first reactant as X, or you can consider the second reactant as X. And what answer you will get, you will compare with the initial answer, which what you have. Calculate the mass of a reagent which we named in 2, which remain at the end of this experiment. So look, we have 0.12 moles of calcium in the beginning. And how many of them are needed or reacted? Out of 0.12, only 0.1 moles of a calcium are reacted. So how many moles will be left unreacted? So how we'll find how many moles will be left unreacted? So this is 0.12, what we have total, minus how many are reacted, 0.1 are reacted. So how many moles will be left? 0.02 moles will be left unreacted. Means these are the moles of a calcium which does not react. But in the question, we need the mass of a reagent that is unreacted. So how we'll get the mass? We have the formula moles equal mass in gram divided by molar mass. So moles of the calcium are 0.02, which are unreacted. Mass we don't know, and the molar mass of a calcium is 40. So this 40 is divided, other side it will be multiplied. So it will be 0.02 multiplied by 40. So what mass of a calcium will be unreacted? It will be 0.8 gram of the calcium will be unreacted. Another example. The second one, how I get, we were having 0.212 moles of calcium, okay? And out of 0.12, 0.1 moles reacted. So this is what we have, the total, and this is the amount which is reacted. So how much will be unreacted? How many moles will not react? So when we subtract 0.12 minus 0.1, so 0.02 moles will be unreacted. And these 0.02 moles which are unreacted multiplied by molar mass, atomic mass of a calcium, will get the mass in gram, which will give us 0.8 grams of a calcium which is unreacted. Another question. 6 grams of cobalt to carbonate was added to 40 cm cube of concentration 2 mole per dm cube hydrochloric acid. Show that the cobalt carbonate is in excess. So we have to show by calculation that the cobalt carbonate is in excess. First part, the number of moles of HCl. So to get the number of moles of HCl, we have the volume. We have the volume of HCl and we have the concentration. So to get the moles of HCl, the moles for a solution is equals to concentration into volume. Remember, the volume should always be in decimeter cube. Most of the question you will find the volume is in centimeter cube. So you have to convert it into centimeter cube. So sorry, decimeter cube. So it is 2, concentration is 2, and the volume is 40, and then divided by 1000. So it will be 40 divided by 1000, which is 0.04, multiplied by 2, which is 0.08. So the moles of HCl will be 0.08. Then mass of 1 mole or molar mass or molecular mass is given 119 for cobalt carbonate. Number of moles of cobalt carbonate in 6 grams. So how to get the moles? So the formula is moles equal mass in gram divided by the molar mass. The mass in gram of a cobalt carbonate is 6 and the molar mass is given 190. So 6 divided by 190, that is 0.05 moles. So what we have HCl. How much HCl we have? 0.08. And we have cobalt carbonate, and how much it is? That is 0.05. Now we want to determine that cobalt carbonate is in excess. Excess means like more than enough or too much. So how we can repeat, these are the quantities which we have. Now we'll compare the ratio between cobalt carbonate, which is 1, and HCl2. So cobalt carbonate and HCl, the ratio between them is 1:2. So if we have, it's up to you, any one of them you can consider that as X. Like example, if I consider cobalt carbonate as X, so HCl I will take 0.08. So 0.08. So 1:2 is the ratio. If we have 0.08 moles of HCl, X moles of cobalt carbonate will be there for a reaction. So when we cross multiply and simplify this, so it will be 2x is equals to 0.08. So if 2x is 0.08, x is equals to 0.08 divided by 2, which is equals to 0.04. So 0.04 moles of cobalt carbonate are needed for a complete reaction. Or these are the moles of a cobalt carbonate which will, you can say, react. So 0.04 only react, but we have how much? We have 0.05. So which reagent is in excess? So we have cobalt carbonate in excess. So explain why cobalt carbonate is in excess. So for a complete reaction, so 0.04 moles of cobalt carbonate will react out of 0.05. That's why cobalt carbonate is in excess. 20 cm cube of sulfuric acid of concentration 0.3. So we have the volume, but volume is in cm cube. Remember, you have to convert the volume in decimeter cube. And the concentration is 0.3. Was added to 40 cm cube of sodium hydroxide of concentration 2. How many moles of sulfuric acid were added? So how to know the number of moles of sulfuric acid? So to get the moles of a solution, it is concentration into volume. So moles of a solution equal concentration into volume. So concentration is 0.3 and the volume of a sulfuric acid is 20, but that is in cm cube. So we have to divide by 1000 to convert into decimeter cube. So 20 divided by 1000, 0.02 multiplied by 0.3, which is equal to 0.06. So this is 0.06 moles are there for sulfuric acid. Now to get the moles of sodium hydroxide, we have the volume of sodium hydroxide and we have the concentration. So again, we'll use the same formula. The concentration into volume, the concentration is 0.2 and the volume of a sodium hydroxide is 40 divided by 1000. So 40 divided by 1000, 0.04 multiplied by 0.2, which is equals to 0.008. So this was 20 divided by 1000 and 0.02 times 0.3. This was 0.006 and this is 0.008. So these are the moles which we have. Now we want to find which of the reagent which we are limiting and which one is in excess. So how to do this? Again, we'll take a ratio between the reactants only. So what is the ratio between the reactant, the sodium hydroxide and sulfuric acid? When they react with each other, the simplest ratio between them is 2:1. Like when 2 moles of sodium hydroxide, there will be 1 mole of sulfuric acid. So if we have, like example, you can take this sodium hydroxide as X. So how many moles of sulfuric acid? 0.006 moles. So if we have 0.006 moles of sulfuric acid, X moles of sodium hydroxide will be there for a reaction. So we cross multiply. When we cross multiply, the value of the X will be 0.012. So X is 0.012. So these are the moles. These are the moles of sodium hydroxide which we need for a complete reaction. For a complete reaction, we need 0.012. But we have only 0.008. So we have less than what we need for a complete reaction. So what does it mean? It means sodium hydroxide is a limiting reagent and sulfuric acid is an excess. Because we have only 0.008 moles of sodium hydroxide, and for a complete reaction, we need 0.012. So we need more than what we need. That's why this is what we need and this is what we have. So we have 0.008, that is a small quantity compared to what we need for a complete reaction. So limiting reagent is sodium hydroxide and excess reagent is sulfuric acid. When you are writing, yes, you can show your working. In the explanation part, you can show your working, you will score the marks. For reasoning, you can write in words. For reasoning, you can show your working in the reason part, you will score the marks. Like here, if I write here, excess means we have more than enough. So when I compare them, as you can see, for sodium hydroxide and sulfuric acid, H2, the reaction is there between sodium hydroxide, NaOH, H2SO4. So according to equation, if we have 2 moles of sodium hydroxide, we will have 1 mole of sulfuric acid. So ratio between them is 2:1. So if we have sodium hydroxide, like example, we have 0.008 moles, then how many moles of sulfuric acid are needed? X. We cross multiply. So when we solve this, 2x is equals to 0.008. When we divide them, it will be 0.004. So these are the moles of sulfuric acid which we need for a complete reaction. So 0.004 moles of sulfuric acid are needed for a complete reaction, but we have more. We have more than 0.004. We have 0.006. So that's why sulfuric acid or H2SO4 is an excess. Is it clear, this example?
Yes, sir, clear.